Good morning, everyone. Today we'll be reviewing assignment number 6 with the theme of principles of counting. We'll be looking at question number 1 and using the game of checkers. A piece can only move diagonally in one space at a time. If a checker makes it all the way to the other side of the board, it becomes crowned. And how many different routes can the checker in the bottom left corner of the board make it at the top row in exactly 7 moves? Okay, that is going to be our key, 7 moves. Explain your reasoning. So as you can see here, we have our game board. We have the checker piece in the bottom left corner and the black space. Our objective is to make our moves all the way up to the top here in exactly 7 moves in order to get crowned. And we'll have to calculate how many different routes we were able to take to get to these 4 end pieces here. So if we begin, our checker piece can only move one spot, so that is one route. So there's one route to get to this black spot, this black space, and to the next spot, there's only one as well. So as you can see, I'm just kind of making my way up the board and figuring out how many routes it takes to get to a spot. As you can see, we're only able to use one route so far. And to make to the end of the board, I use 1, 2, 3, 4, 5, 6, 7. 7 moves, exactly 7 moves to get here. And there's only one route. So we've figured out one end piece so far. We have to figure out the rest of the 3. In order to do that, we'll have to come down here and look at this black spot here. We can see that there's only one route to get here. This is where it kind of gets a little tricky and a little more fun. As you can see here, there's one route here and another route here to get to this black space. Okay, so if we do 1 plus 1, that gives us 2. Okay, and since we've already established there was 2 different routes to get here, and there's only one here, we can move the 2 up here. So there's 2 different routes to get to this black space. All right, how about this one? We do 2 plus 1 equals 3, so there's 3 different routes there. And how about here? 3 routes plus 2 routes equals 5. Okay, we're kind of getting the hang of this now, are we? How about this one? Well, 3 routes plus 1 equals 4. And same thing here. We'll move the 5 up here since we've already established there's 5 different routes and there's only one here, so we'll move the 5 there. How about this one? So if we do 5 routes plus 4 equals 9, and 4 routes plus 1 equals 5. Great job. So how about this one? This one, we can do 5 routes plus 9. So if we borrow a 1 from 5 and hand it to the 9, that'll give us 10. Gives us a little easier number to deal with. So we can do 10 plus 4 equals 14. And here is we can do the exact same thing. 9 plus 5 or 10 plus 4 equals 14. And 5 plus 1 equals 6. Great job. So to get to this black space, there's 14, and this one 14, and this one 6, and this one 1. Those are different routes. And as you can see here, we did not use any of these black spaces because if we were to use any of them, we'd be going over our move limit, which was 7. So by using the addition principle, we can add the 14 plus 14 plus 6 plus 1 equals 35. So there are 35 different routes from the bottom left corner to the top rows using exactly 7 moves. I hope you enjoyed that. Thank you.